Okay, now we're going to try to figure out how we can use this idea of z-score to answer probability problems that deal with normally distributed sets of data. Okay, so we got this scenario right here. We got this airline. It finds that the travel between two cities has a mean, just an average. The travel between these two cities has an average of 85 minutes. Okay, and they also found that the standard deviation for that travel is about 7 minutes. Okay, standard deviation about 7 minutes. And they're saying just assume that this distribution is normally distributed. So they want us to answer this question. What is the probability that a flight from the first city to the second city will take between 75 minutes and 90 minutes, okay? Knowing this information. Well, here's kind of the flow. I'm going to give you a quick flow. The first thing we have to do is we've got to find the z-scores for both these 75 and these 90 minutes. Once we find the z-scores by putting it into this formula right up here, what we're going to do is we're going to have to use this table down here. It's like a z-score table. And here's how you read the z-score table. Once you find the z-score for something, you find it in this column or this column or this column, right? You find that z-score. Let's say the z-score was -2. When you find it's -2, then the probability that it was either that z-score or less, you kind of look at this table right over here, the probability was that z-score or less is given right here. Okay, that's the probability given right there. So that's how you read this table right here. Let's see if we can use this to answer this question. Now, I just want you to know, and I will say it probably one more time, that if you want to see how you can just do this on your calculator without using that table, just take a picture of this QR code, and then it will bring you to a nice little introduction on how to use your graphing calculator to calculate things like this. But I'm going to leave that up to you. I'm going to show you how to use this table to do this one, okay? So first, let's find the z-score for the 75 minutes right here. Okay, so I'm going to put z, and I'm going to put it as a subscript 75, just so we can just remember which one we're talking about here. And z75, or the z-score of 75 minutes, is equal to our given value, 75, okay, minus our mean, so we have to subtract the 85 minutes, subtract the 85, and we have to then divide that by the 7, our standard deviation. Okay, so that's the z-score of 75. And let's just kind of figure out what that is. We'll put that in our calculator quick. So we have 75 minus 85, so we have -10 divided by 7, and we get a z-score of -1.42. -1.42. -1.42. Okay. Now let's find the z-score for 90 minutes. Let's find that. So the z-score for 90 minutes is equal to our 90 minutes, and then we're going to subtract the 85 just like before, and then we're going to divide by the 7 just like before. So now we got 90 minus 85, which is 5, divided by 7, divided by 7, which would be 0.714. Okay, so we'll put that in there. This is equal to 0.714. Okay, so now we have these two z-scores, this 0.714 and the -1.42. And now we're going to go down to the table, and we're going to find those two z-scores in this table. Okay, so let's work our way down there. Actually, I wonder if I can drag this down. Nope, can I drag that? So we have that one. We'll drag that one down so we can see that. We'll drag this one down. Okay. So on here we want to find -1.42. Now, this table isn't exact as some other z-score tables. Some z-scores do go to the 100th place or even the 1000th place. This one only goes to the 10ths. So we're just going to kind of round. This is about -1.4, and that is given to you right here. I'll do this one in red. Okay. -1.4 is right there, and the 7.4 or 14, again, we'll just try to find 0.7. That's given to us right here. Okay. Now again, how do you read this table? Well, because this is an in-between situation, we got to make this a little bit more complicated. If they were just asking you what's the probability your flight is less than 90 minutes, okay, that was this z-score right here. The probability is given to you right there. It's 0.758. That's less than 90 minutes. Or if they were asking you what's the probability it's less than the, what was it, 75 minutes, right? Yeah, 75 minutes. That's given you right here, because this is the z-score, so the probability is less than 75 minutes. It's 0.081, okay? That's probably it's less than. That's what this table tells you. The probability is that or less than. But we wanted to find the probability is in between. So if we look at this graph right here, this bell curve, if I were to put this -1.4 maybe it would come out to be here. This is the z-score for the negative 1.4, which was the 75 minutes. And remember, that's shaded all to the left. Okay? Probably was less than that. And the other one, the 0.7 z-score for the 90 minutes would be somewhere, I don't know, right here. Just guesstimating, 0.7. And remember, it's finding the probabilities to the left. Now look at, there's the overlap here. See the overlap right in this area? That overlap area? I'll get it in yellow. That's the overlap. Well, the overlap there, we're just going to subtract the overlap from the 0.7. So really what you need to do is just take this probability right here, the 0.758, and subtract the probability of this one for the in-between, 0.081. So let's just figure out what that is. 0.758 minus 0.081. Actually, look at it, I already have it up here. Is 67.7. So this comes to being equaling 0.677, or 67.7% chance that this flight will land within or in between, what was it, 75 minutes and 90 minutes. The flight will be in between those two times. And that's how you use this table along with finding z-scores to answer a problem like you just saw up there. That's probably one of the more difficult problems that you're going to have to deal with.